Okay, last one for this section, horizontally stretching and shrinking graph. So here we go. Once again, this is horizontally, so we know whatever happens horizontally is completely opposite of what we would think. So this is going to be okay. So let's talk about it. Let f be a function and c be a positive real number. So if c is greater than 1, the graph of y equals f of the quantity c times x is the graph of y equals f of x horizontally shrunk, right? So if it's greater than 1, it shrinks by dividing each of its coordinates by c. Now, if 0 is less than c is less than 1, the graph of y equals f, the quantity c times x, is the graph of y equals f of x horizontally stretched. Okay, so if it's between 0 and 1, it's going to be stretched by dividing each of its coordinates, x coordinates, sorry, by c. So here you can see if it's less than 1, it's or if it's greater than 1, it's shrinking. If it's between 0 and 1, then it's stretching. I put this little thing in so that I could kind of show you why that is, because there are some of you that are just going to be happy with the fact of me saying this, but there's some of you who are going to want to know why. So here's the why. So when k is also a constant, c could equal a constant, or k can stand for a constant. So when the constant, the absolute value of the constant, is greater than 1, then f of x is compressed horizontally by a factor of 1 over absolute value of k. So it's a fraction, right? So then that's why it is dividing. It's because it's a fraction, okay? And then when it's 0 is less than the absolute value of k is less than 1, then it is stretched horizontally by the factor of 1 over k. But if it's between 0 and 1, this is already a fraction, so it's a fraction divided by a fraction, so that would make it a whole number. That's why it stretches, okay? Just in case for those of you who are like, I need to know why. That is why. So here's my simple speak. If you multiply a function by a number greater than 1, it gets narrower. If you multiply a function by a number between 0 and 1, it gets wider, okay? Alright, let's do a couple of these, or at least one. Alright. So here we are given a function, but it's as in, like, it's not written as a function, it is written as points, okay? So what we're going to do is we're going to do our little stretch and shrink on it. So we know that this is horizontal because it is in with the x, so it's horizontal. So since it's going to stretch it's going to either stretch or shrink, we know that our x's are changing, but our y's are not. So y's stay the same. Okay? I think I'm about to sneeze, so please forgive me in advance. Okay, so let's just start with our original f of x, which is this guy. So let's write down our points, shall we? We have a -2, 0. Our next one, 0, 3. Then our next one is 2, 0. 4, -3. And last but not least, 6, 0. I'm not off the paper. Okay, you can still see me. Okay. So this is our f of x. Now, let's do our first transition, which is going to be f 2 times x. So it's going to be 2x, right? But we know, since it says 2, that 2 is greater than 1, so we know that's shrinking, right? And from that second little square that I had, we know that it's going to shrink, so we're going to multiply by 1/2, right? Because it's in the form of 1 over absolute value of k, so 1 over absolute value of k. That's our constant. So we know the y's stay the same, so we can copy and paste them. So let's do that. 0, 3, 0, negative 3, 0. Cool. Now, we're going to take 1/2 and multiply it times all of our x's. So 1/2 times a negative 2, yep, negative 1, 0. 1/2 times this, 1, 2, commas, and then 3. Everybody good with that? Okay. So I really should have, what was that, graphed this one first. So let's do him. So negative 2, 0, sorry, back up. 0, 3, 2, 0, 4, negative 3, and 6, 0. Alright, sorry. Teacher not doing what she should. Alright, so that was our original. Now let's do our shrink. Okay. So this one we're going to have negative 1, 0, 0, 3. So he's going to go here. 1, 0, 2, negative 3. Because remember, our x's stay the same, so they should be the same height. And then 3, 0. So, I don't know. So 2x did shrink him, right? He's a little squattier, I guess would be a good word for him. Okay, cool. Now let's do, I'm going to have to pull this over a little bit. Give me some more room. Ooh, terrible straight line. Now let's do the last one. So our last one is 1/2 x. Now remember, it's a stretch if 0 is less than, let's say k, is less than 1, right? Now since the 1/2 is in here, we're going to multiply by what? 2, right? Because it's 1/2 of 1/2. Anyway, so that would be 2. So if we multiply, we copy and paste our y's again. 0, 3, 0, negative 3, 0. Now we're going to multiply 1/2. Sorry, that's not right. 2. Multiply 2 times our original. So 2 times a negative 2 gives us a negative 4. 0, 4. This one is going to be 8. And then 12. And then we just graph those. So negative 4, 0, 0, 3, got here. 4, 0, 8, negative 1, 2, 3. And then 12, 0. So if this is 10, 11, I'm going to say 12 is about right here. Okay. And there's our stretch. Okay. I said at the first, I put the order of transitions at the first and at the second, at the beginning and at the end would be a better way to say it. So here they are again. I don't know why it says 5, 6, and 7. This should be 1, 2, 3, and 4. Let's correct that. There we go. Don't know about that. Always something fun when you do notes. When I do notes, maybe. Okay, now let's work this one out real quick, and we will be finished. There's one like this in your homework. That's why I threw this at the end. I put this in the homework, and then I was like, hey, this is kind of something maybe a little tricky, so I wanted to work it with you guys. I had to put this underneath this paper real quick, so I'm sorry, but I can't stand my pen ticking on the cabinet. So, hang on. Alright, back with you. Alright, so this says to write an equation for the graphed function by, using transformations of the graph of one of the toolkit functions. So, here's our toolkit. This guy looks very much like this guy, right? So it's the quadratic, which we know is x squared. So that's what our base is, what we're working with. That's why I put that toolkit in there in front. So, so the parabola. Always graphs like x squared, okay? And its original vertex, remember vertex is the point at which it changes directions. Original vertex is at 0, 0. Okay, those are some things that we need to know to start this. Okay, so but instead of this one isn't at 0, 0, right? It's been moved, so let's talk about that. Okay, so this one has been moved down, how many spaces, and it's been moved to the right. How many spaces? Well, if it's sorry, if it's at 0 and it's been moved down, well, 1, 2, 3. So it's been moved down 3 spaces, and it's been moved down to the right 1. So we know to move down is a vertical, right? So this guy is vertical, and he's always separated, either by a plus or a minus. But to go down, you know he's separated by a minus sign, right? Okay, let's talk about this guy with the different color. He's moved to the right, so that's a horizontal shift. Now, horizontal shifts are in, they're not separated. So when they're not separated, they're always denoted with the opposite, right? So if he's moved to the right, we would write him in with our x as a negative, right? So let's think this through. If we start our whole thing with, we know it's x squared, but we in with the x, we have to have minus 1. So we would write this as, I'm going to just say f of x, okay? It's going to be our function name. We're going to have x, in with our x, he moved to the right, so it has to be minus 1. But our function was squared, because it's a parabola. But then he also moved down 3. Okay? That's how we do it. Cool? Alright. I hope that made sense to you guys. If not, well, come see me, rewatch the video, holler at me, go to tutoring, something like that. Okay? Alright. Well, I hope you guys have a very blessed day, and well, I'll send you another video soon. Okay. See ya.